And let's use some trig the inverse way. So most of the way we're going to do this is going to be the same. We still need to use one angle and two sides. And since that's three variables, we ideally should know two of them. In this case, there's an angle we're supposed to find, so it seems pretty clear that we should use that angle there. And then there's two sides that we know. So I know this value here, and well, relative to the x, that's the adjacent side. It's next to it. And then the other side that's next to it, well, that's got to be the hypotenuse. And we can verify that by verifying it's across or opposite the right angle there. So this is going to be our hypotenuse. And then I just have to figure out which trig function to use. And so looking through them here, I have the adjacent side and the hypotenuse. So I'm looking for an A and an H. It's not there. It's going to be cosine. So it's cosine of the angle, which in this case is unknown. And that must be equal to the adjacent side, 5 in this case, over the hypotenuse. Now here's the problem that we're running into, is that the cosine function itself is set up to where we input an angle and it tells us the ratio. But in this case, we don't know the angle, we know the ratio. That's where the inverse comes in. So the inverse arc cosine of the ratio is going to tell us the angle. So this can actually just be rewritten as the arc cosine, two C's, of the ratio 5 over 11 will tell us the angle, which in this case is x. So what is this doing? Well, this is saying, hey, you know what? Figure out what right triangle has a cosine ratio of 5 over 11 and tell me the angle that would give you that cosine ratio. And there's actually just something on your calculator. I'm doing that off screen that'll tell you that. It's usually second and then you hit the cosine button. So I'm actually just going to rewrite this real quick. X degrees equals the arc cosine of 5 over 11. That's actually our exact answer. But just like before, the more useful answer is more likely to be our approximation. All right, so let's go ahead and get that approximate angle, which is just 62.96 degrees. And we can put that up in our diagram here. At this point, because of the amount of information we have, there's not really a way for us to error check this too well. Obviously, if that had come out to be, 2 degrees or 500 degrees, we'd know there was probably something amiss. As it is, we have both our exact answer and our approximate solution here, and a pretty nice, simple example of how we can use trig functions to not only find missing sides, but also to find missing angles.